Dear students, in the last lecture we have discussed about the harmonic distortion analyzer, and in this lecture we will discuss about the spectrum analyzer, that what is spectrum analyzer and how the spectrum analyzer works. The electronic instrument that is used for analyzing waves in frequency domain is called spectrum analyzer. But what is spectrum analysis? Actually, spectrum analysis is defined as the study of energy distribution across the frequency spectrum of a given electrical signal. So, for the analysis of a signal or the spectrum analysis of a signal, we need an instrument that is called spectrum analyzer. Basically, it displays the energy distribution of a signal on its CRT screen. And also spectrum analyzer gives information about amplitude of all the frequency components of the input signal. Generally, what we see is the most common way of observing a signal is to display them on CRO, and there on the CRO we take the on the x-axis we take the time, and on the y-axis generally we take the amplitude. This is called time domain representation. But spectrum analyzer provides the frequency domain or the frequency representation of a signal, in which on the x-axis we use the frequency and on the y-axis we can see the amplitude. Also, sinusoidal components of the input signal is displayed as vertical lines on the graphical display of CRT, and the height of vertical lines represents the magnitude and the horizontal location represents about the frequency of a signal. Here there is a block diagram of spectrum analyzer. Actually, it is super heterodyne spectrum analyzer. The spectrum analyzer used for analyzing the signals which are of RF range is called super heterodyne spectrum analyzer. In this block, we can see the various blocks like adjustable attenuator, which is used for to adjust the signal in the range if the amplitude is large. There is a filter which is used to for the that the frequency components less than cutoff frequency are can be allowed to pass. There is a mixer which is used which get the input from low pass filter and VCO, and it produces an output which is the difference of the frequencies of the two signals that are applied to it. Next, there is a detector and video amplifier. The use of detector is the output of detector is given to vertical deflection plates of CRO. So CRO display the frequency spectrum of RF signal on its CRT screen, and the tunable oscillator receives the input from the sawtooth generator. In this way, we can explain the different blocks of the spectrum analyzer. Now we'll see that how these blocks works, or what is the working of spectrum analyzer, or how the spectrum analyzer display a frequency version of the signal on its CRT screen. The signal which is to be analyzed is applied to the input attenuator, and if the signal amplitude is too large, that it can be attenuated by the input attenuator. After the attenuation, the signal is applied to a mixer where it is mixed with the output of variable frequency oscillator. Actually, the variable frequency oscillator is a VCO or voltage control oscillator whose output frequency depends upon the applied sawtooth voltage, and this sawtooth voltage receives from the sawtooth generator. The process of mixing of input signal frequency with output frequency of oscillator is known as heterodyning, and that's why this type of spectrum analyzer is also known as super heterodyne spectrum analyzer. And the sawtooth signal which is applied on the sawtooth generator to the tunable oscillator, this sawtooth signal is also applied to the horizontal deflection plates of CRT, so that separation of display of various frequency components on the screen can be achieved. The sawtooth generator sweeps the VCO linearly from minimum to maximum frequency range. So it is also known as swept spectrum analyzer. This type of analyzer is also called swept spectrum analyzer because of the sawtooth generator sweeps the VCO linearly from minimum to maximum frequency range. And when sawtooth signal starts to increase from its minimum value, there are two phenomena occurs. What are these phenomena? Firstly, what happened? Frequency of oscillations starts to increase, means the oscillation frequency will rise, and spot on the screen starts traveling in horizontal direction, means the spot will now travel in the horizontal direction on the screen. As the oscillator frequency increases, the fundamental components of input signal is filtered out from the active filter. This filtered signal is then detected, it is amplified and supplied to the vertical deflection plates of the CRO. Hence, the spot on the screen is deflected. After that, when the voltage of sawtooth generator increases, there is a frequency of oscillator also increases, and so second harmonic component is filtered out, and after detection and amplification it will reach to the vertical deflection plates of CRO. Meanwhile, increase in voltage of sawtooth signal causes little movement of the spot comes to another point. Hence, the voltage of sawtooth wave rises and third harmonic component is filtered out. So, this process is continued to next harmonic and a complete display of fundamental frequency with harmonics can be visualized. So in this way, the output of detector is given to vertical deflection plates of CRO, and the output of sawtooth generator, that is a sawtooth signal, is applied on the horizontal deflection plates of CRO, and CRO displays the frequency spectrum of signal on its CRT screen. So in this way, spectrum analysis works and it displays the frequency domain representation of a signal that is to be analyzed. There are various applications of spectrum analyzer, or there are various fields in which we can use the spectrum analyzer. As firstly, we can study the different type of modulations through the spectrum analyzer. We can also study the harmonic distortion through the spectrum analyzer. We can also measure alternation through the spectrum analyzer. The spectrum analyzer also gives the bandwidth details of a signal. Some spurious signal effects on input waveform can be analyzed through the spectrum analyzer, and we can also measure the different type of antenna patterns through the spectrum analyzer. So these are the applications of spectrum analyzer.